Hi and welcome to our next mini lecture on pre-calculus. Here the question is graphing the inverse of a function given its graph. It says below is the entire graph of function f. Graph f inverse, which means the inverse of f. Well, this problem is very simple to do. If we notice the following: if a point with coordinates, let's call the coordinates a, b, is on graph of f is our original function, then the point with coordinates BA, just a flipped version of what we have of here, is on graph of f inverse. So let's take that and run with it and do the graphing. Then I come back and explain this, which we have explained once before when we talked about the inverse function. So we go look at our points here. Here's a point with coordinates that looks like it's 8 and 7. So we go ahead and find its sister point. Let's call it 7 and 8. 7 and 8 will be here. So if the red one is on the graph of, let's call the red one, this one, graph f, and the inverse we are going to plot it in green, then 7, 8 is going to be on the green. Now let's go look at the next point here that's easy to detect. That's the point with coordinates 3 and 6. Okay, so this is 3 and this is 6. So what's a sister point? It has to be 6 and 3. So 6 and 3, that's going to be here. So if on the function I go from, let's call this thing point A to B, then on the sister function or the inverse function, I'm going to go from this point to this point. And so on, we continue. We go to the next point. Here I have minus 2 and 3. I flip that, so I'll have the point with coordinates 3 and minus 2. So took the coordinates, flip the order, and now say I come here on this dotted line. Here I'm going to come down on this dotted line. Or dashed line if you wish. Finally, this point here has a coordinate, looks like it's minus 5 and minus 3. If I flip them, I'm going to get minus 3 and the minus 5 that's here, and okay, let's make this one dotted line and do the same thing here. Now that's what you have to do with the graphics that is available to you. You connect the dots and then you get the graph. If you pay attention, you see that these two graphs are reflections of each other in the 45-degree line. This is the so this is the line y equal to x, sometimes referred to as the 45-degree line because it makes 45 degrees here. graph of a function and its inverse functions are reflections of each other in the 45-degree line. That's one way to help you to get the graph. Finally, to explain what is this mystery that if AB is on the graph of F, then BA is on the graph of F inverse, let's go ahead and take a look at a function you are familiar with, say y equal to x cubed. If you make a table for this thing, what are entries on that table? X and y. For example, 0, 1, 2, 3. Cube of these things will be 0, 1, 8, and 27. What's the inverse of this function? Well, that's y is equal to cube root of x. What's a table for this one? If I have x and y, instead of using these numbers, which is going to make me get stuck with finding cube root of some rather unfriendly numbers, we might as well use these. So it's going to be easier if I use 0, 1, 8, 27. Cube root of these things are going to be 0, 1, 2, and 3. Now if you pay attention to the situation here, if I have for example 2, 8 on a graph of the function f, then I have 8, 2 on the graph of its inverse. So if this is x cubed is my original f, then cube root of x is f inverse. And what we said before is that the inverse function is simply the original function with the two columns changing their spots. That's all that's happening. So if originally you had 2, 8, then in the inverse table there's going to be 8, 2. And these two go hand in hand, and they'll be reflections of each other in the 45-degree line. And so if you have a function, you have a graph of a function, you want to graph its inverse, all that you have to do is to exchange the coordinates or flip it across the 45-degree line. Or another way to think about it is that this is a mirror, and you are finding the reflection of the graph that you have in that mirror. So that is what's happening here. So we already got to the end of this short lecture. Until next time, good luck and God bless.